Hello everyone, welcome to our lesson 5. In our last lesson, we explored how to use music features to create interactive experiences. Today, we'll continue our production guide by shifting focus to another powerful sensor, the gyroscope. This session is all about how to use gyroscope functions to create your own work. The core idea here is gyroscope-based interaction. This type of interaction is defined by an immersive concept: move the phone and the content moves with you. It uses the device's built-in gyroscope to detect tilt and rotation, transforming physical movement like tilting, rotating, or shaking your phone into direct control over visuals, gameplay, and interactive responses. It turns the entire device into an intuitive input controller. Now we see this example. So let's see how we build this through our iterative prompting process. So we know that visual feedback is precise, unambiguous, and faster to correct. So when the result is almost right but has specific spatial issues like position, overlap, scale, or visual issues like style, mismatch, or blocked elements, a circle says more than a paragraph. We can just screenshot the result, circle the problem area, then reference the circle in the prompt. As seen in this example, the user uses prompts like remove something in the red circle to describe the problem. Then Loopit can understand the description and deal with it. Now let's take a look at the details of the prompt design method. So we start with round 0, the base prompt. Here our goal is a small shooting game. The prompt establishes the core gyroscope mechanic. The player aims using the gyroscope and taps the screen to shoot. It also sets a scene, a shooting range, and the goal scoring points. This gives us a functional but often rudimentary starting point. So we can see some shooting games. This is a standard shooting game. And this is another one. In round 1, we want to improve the embodied control. Sometimes the aiming feels abstract, like simply rotating a camera view. Player does not feel like they are holding the weapon. We need to enhance the sense of embodied interaction and physical realism of aiming. We instruct the system to create a stronger physical metaphor. Make the gun-holding hands move together with the camera and gyroscope input, so the player feels they are physically aiming the weapon with their hands. This shifts the experience from observing a scene into inhabiting an action. Round 2 typically addresses multiple refined issues. The hand model may block the crosshair, and aiming may feel visually uncomfortable. Here we focus on 2 critical fixes: visual clarity and functional UI layout. We request a layout change. Adjust the position of the hands and the crosshairs so they no longer overlap. Ensure the crosshair remains clearly visible at all times. Round 3 corrects gyroscope axis mapping. Horizontal and vertical aiming feels inverted, or gyroscope movement does not match intuition. Then we need to ensure sensor correctness and natural motion mapping. We give a direct technical instruction. Invert the gyroscope x-axis and y-axis so that device movement matches natural aiming behavior. This makes the control feel immediate and correct. To summarize, creating compelling gyroscope-based work follows our core Loopit principle. Gyroscope prompts require physical intuition, and each round improves a different layer. functionality, embodied feeling, visual usability, and sensor correctness. We also need to make it clear that what does the gyroscope control? Does the object move or only the camera? Are hands, crosshair, and target visually separated? Are axis directions explicitly defined? Through this structured round-by-round process, we transform a simple motion input into a playable experience. Now, that's all for the lesson 5. Thanks for your watching.